Okay. Hope this records. A lot of you are confused on how to solve problems. So this is I hope you see, I hope you hear. This is week 3 homework. So I'm gonna go to the very bottom right here and show you with this problem what to do. So you can solve the problems the appropriate way. So when you're solving problems in physics and you get to the final answer, there are 3 questions you have to ask yourself. Do I have the right significant digits? Does my answer make sense? And do I have the appropriate units? First of all, if the question doesn't have the appropriate units, you have to convert before you start solving. You have to be in SI units unless the problem asks for something else. If nothing else is said, all need to be in SI units. Then you have to put the given. No physics problem can be solved without the given. You have to decode the problem and you have to use symbols and you have to use formula. Some of you directly put numbers. This is not physics. This is anything but physics. So let's read this problem and see how to approach it. A hockey puck, I apologize, I didn't mean to do that. Okay, just let it be. I don't know how to erase it. Okay, here you go. A hockey puck with mass 0.3 kilograms is sliding along ice that can be considered frictionless. The puck's velocity is 20 meters per second when it crosses over onto a floor that has a coefficient of kinetic friction 0.35. How far will the puck travel across the floor before it stops? Okay, so we have one-dimensional motion here in one direction. So a reference frame really not necessary, but if you want, you can put your reference frame there. So you're moving to the right, you consider everything to the right positive, everything to the left negative. So let's start step by step. It says a hockey puck with mass, and we see it's in SI units. So all we have to do here is write M equals 0.3 kilograms. You can't just copy the problem with the word mass or something else. The symbol for mass in physics is lowercase m. If you have more than one mass, then you can call them M1, M2, M3, but it has to be lowercase m in most cases. Sometimes you might choose to use capital M, but then you will have to tell me that. It says it's sliding along ice that can be considered frictionless. This here means you do not have a force of friction. So you do not have to consider the force of friction. The puck's velocity is 20 meters per second when it crosses over. So the first velocity that we know, it's 20 meters per second. So this is our initial velocity. You have to name it. You have no choice of the matter. So it's either V0 or VI. That's up to you. I prefer V0. You can put VI. It's up to you. So this one is 20 meters per second. Also SI unit, so I don't have to convert anything. Okay. When it crosses over into a floor that has a coefficient of kinetic friction 0.35. So now a friction force appears. So the friction coefficient is lowercase f, and here k for kinetic equals 0.35. Now the friction coefficient doesn't have units, so you shouldn't be concerned. Now we are asked how far will the puck go? So we're asking for displacement. And because you're on the x-axis, you can call it x, you can call it d. It's up to you again, but it has to be clear that that's what you're solving for. So I'm going to call it X. So how far will the puck travel across the floor before it stops? So here we have additional information. It says before it stops, which means our final velocity is 0. And of course, you have to have the units, 0 meters per second. Okay, this is the given, and this is what you are looking for. So at that point, you have to decide what to do, how to solve it. You don't have time, so you have to avoid any formula that has time. But you have initial and you have final velocity. Now, because you are on the week of forces, you will have to here draw a free body diagram. So we sometimes abbreviate it as free body diagram like that. So if you see that FBD, that means free body diagram, which means you'll have to draw the situation and all the forces that are acting. So what do you have? You have something that it's sliding across. So first you have the force of gravity, mg down. You can call it Fg here. That's up to you. Again, then you'll have normal force, of course. Normal force, because you have a surface. And on this one, you do have force of friction. Force of friction. This is your free body diagram. This is all, by the way, in the given. You have to have that. And as I said, if you want, you can draw your reference frame, which is a standard reference frame, XY. You don't really need to, but you have to consider that this is your reference frame. So now what am I trying to find? I'm trying to find the distance. It's displacement, but in this case, distance and displacement are the same thing because you're just moving in one direction. So the only force that it's acting in that direction that you're moving is the friction force. So if you're trying to find the friction force, for example, friction force, this is in the x-axis, right? In the x-axis, the only force that is acting is the friction force. So the friction force that should say Fr here for friction, equals, by definition, is the coefficient of friction times the normal force. Now, if we see from the free body diagram, though, the normal force here equals mg because there are no other forces. So the sum of these forces here equals 0, and because they are in different directions, Fn is basically mg. So here you're getting mu k mg. So the friction force basically we can find, but you do not use numbers here. So we have already expression for the friction force where we know everything. G is 9.8, m I have, and coefficient of friction, it's also given. Now, this of course is with a negative sign here, but in this case, of course, the rule tells that you have to put the negative sign because if you look at the reference frame, the friction force is in the opposite direction. So technically, this should have a minus here. To be absolutely correct, your friction force is negative because it acts in the opposite direction. Now, the friction force is the only force that it's acting in this direction. So in other words, Newton's second law is going to be ma equals the sum of all forces that are acting here, but the only force acting is this one. So negative mu k m g. Now, if you notice here, the m's are going to cancel. Now, this is one of the reasons why you don't want to work with numbers, because sometimes you might not see that. So now I have the acceleration. I just found what my acceleration is. I hope you can take it from here, because all you have to do from this point on is one of the kinematics equations, which is v final squared, I hope you can see here, minus v initial squared over 2a. Again, this is hard to hear. That should be an a here. Okay, it doesn't let me do that. I'm sorry. I'm too like too out of the border. But yes, you have to do vf squared minus v0 squared over 2a equals x, what you're trying to find. And you have the two velocities, and you just found a, but first you're going to solve it as a expression. And only then, when you have the formula and the expression for x, you're going to substitute. Sorry that I couldn't finish this, but I hope you can take it from there. So this is the way to solve problems in physics. You have to decode the problem, put the symbols there. If you need to do a reference frame, do the reference frame. If you have to do a free body diagram, you have to do a free body diagram. And from there, you solve only with the expression until you get an expression for what you're looking for. Only then you can put the numbers. I'll try to do that problem better and post it someplace. I don't know if I will be able to write it someplace. Maybe I can do it, record it in Miro.